Hello, how are you guys? Hope that you are doing well. So today we are going to discuss about the very important and variable test, which is Marshall stability and flow test. So Marshall stability and flow test is play a very important role in the construction field during the designing and construction if of any type of road or highway related. So if you are going to any type of site engineering job, then you definitely have a need to prepare and have knowledge about these tests. So what is comes in introduction, why we are saying this test as Marshall, because the developer name of this test is Bruce Marshall. So by the name of Bruce Marshall, we can say it Marshall test. So Marshall stability test basically we are doing for checking the resistance to plastic deformation for bituminous material and its maximum strength. So we are going to basically output the Marshall stability and flow test, provide the performance prediction measure of the manual mix design method. The stability portion of test measure the maximum load spot by the test specific the loading rate on which we can apply the load. The standard of the load is 50.8 millimeter per minute. Okay, so load applied in a specific failure and maximum load distinguished by as a stability. So as we have, I say that the Marshall stability test is applied to check the resistance of plastic deformation, bituminous material and its maximum strength. So what is an objective? Objective is to determine the optimal binder content of an asphaltic material that it will give is maximum stability. So here is some important definition and some important point which you must to be know, in which durability, what is durability, what is workability. Durability is, you can say as advice, repeated traffic load, combined effect of. So these all type of comes in the durability. And workability, the make sure be capable of being placed and compacted easily. So here is some other, but you just need to read this is its line. If I can explain it, then video will be go too long. So here is the apparatus. In the apparatus we can see a specific mold assembly. It is specific mold assembly, specific extractor, compacted rammer. It's a rammer and seen as pedestal used for compacting mold. Pedestal we can apply. Here is the mold. This type of things are coming. It's apparatus. So braking head. What is braking head? Leading machines and flow meter. Okay. So where is braking head and same others. So here is what is the procedure. Procedure is basically that initially we are just preparing our mold, dry sample of 1200 grams, and then we are going to bituminous material which the initially prepared by the temperature of 150 and 165. The mixing temperature is 145 and 160, and fill the maximum strength with.
So after 24 hours, core of mold and take weight in water and leave the core water bath for 30 minutes at 60-degree temperature. So after 30 minutes, we can take ore from the bath and note down its weight in air, which is we can see SSD. SSD stand for saturated surface dry weight. So put the core into breaking head and then note down deflection and load. What is deflection head? Here you can just put the load which are in the mold, and after that you can just apply the load, and one needle is for that showing how much deflection, and the other needle is showing how much you are load applying. So after note down the deflection and load, the providing rank reading will be in millimeters, which you have need to multiply 0.021 to convert into kilonewton. And basically we are going millimeter to kilonewton. So after that we have need to find four things. First one is bulk specific gravity. It's according to ASTM. It's a standard ASTM code C127 NH2 P166. Basically, what is bulk specific gravity? The ratio of weight in air of unit volume aggregate standard temperature of weight in air equal to the volume distilled water at static temperature. So here it is formula G is equal to P1 plus P2 and so on. How much you have P? What is P? P is a individual percentage by mass of aggregate. Okay, and G is the individual coarse fine bulk specific gravity of aggregate. Okay, the second thing is maximum specific gravity. Its code is ASTM D2041 and ASSTO T209. If you are following another code, then you are just apply accordingly this. So the temperature maximum specific gravity for bituminous mixture is a bulk specific gravity of that mixture compacted to a point of 0 air weight. G is equal to P, and P divided by G. What is G? G is the maximum specific gravity of paying mixture with no air voids, and P mm show percentage by weight, percentage by mass of total loss mixture, and PS show aggregate contact percent by total mass of mixture, and PB is showing asphalt contact present by total mass of mixture. So here is third thing is we need to find is effective specific gravity. It is formula defined as the ratio of mass in air unit volume of permeable material. I can show in the next slide what is permeable material. Okay, so state temperature to a mass in the air. Okay, here it is formula. We can show same as it is PMM, PA, and PB, and same as it is GB. GB is basically specific gravity of a spot. So here I can show what is permeable void portion. One is simple void and one is void after putting bitumen. Void which after putting bitumen is we can say as permeable portion, and the other void which we can fill with bitumen, we can say permeable void portion filled with asphalt binder. And the so here now we are finding VMA. VMA stand for void filled with mineral aggregate. So its formula is we are showing that its formula is 100 minus GAB multiplied by PA divided by GAB. What is GAB? We have know that we have found already in previous slide, which is bulk specific gravity of total aggregate. Same as these are the details. Okay, so next one is percentage air void in compacted mixture. It's a fourth thing which is same as it is to the previous one, but little much is different. Okay, you just follow these guidelines. So the next one is VFA. VFA stand for the void filled with asphalt. Okay, so here it is formula VMA void mineral aggregate, and same as this VA air void compacted mixture percentage. Okay, so after that optimize binder content, which is we need to find at the end of result. Okay, so its formula is B1, B2, B3, and B1 we know that optimal binder contact. B1 is percentage small contact maximum inlet weight, same as with B2 and B3. So here is a chart by which we can compare our values by percentage of VMA, VFA, and same as it is flow rate, stability, to check where the flow, where the graph line will show us. Okay, I think that is enough. Okay, good luck, take care, and if you like this video, then please subscribe it and follow it. Okay, thank you.